Let's now talk about byte pair encoding, which is an algorithm that will help us to take our tokenizer to the next level. So byte pair encoding is an algorithm that has been around for about 30 years or so, but it's really popular for implementing tokenizers these days. And for example, GPT-1, GPT-2, 3, and 4, they are all using this byte pair encoding algorithm for their tokenizer. And even other companies, for example, Meta AI for their recent Llama 3 models, they're using byte pair encoding. And so byte pair encoding really helps us addressing one major shortcoming of our tokenizer. So if I go up again a few cells here, one of the shortcomings of our simple tokenizer was that it wasn't able to handle unknown words. So for example, in this case, we had this word hello, and since hello was not represented in the training data, it would raise a key error. And so the way we handled that was that we replaced unknown tokens by the unknown placeholder token here. So we had this special rule here to replace anything that is not contained in the vocabulary, so anything that it hasn't seen during the training, by these so-called unknown special tokens. So what happens is, for example, if we have some text like this here, so these unknown words get replaced by UNK placeholder tokens, and this one as well. But the main shortcoming of this is now to the LLM, this all looks the same. So the LLM doesn't really know what's here and what's here because it receives the same token ID for both of these cases. And in many real world tasks where you have specific names or anything that were not included in the training data, the LLM wouldn't have any idea what you're talking about or what you're referring to if you have multiple of these unknown tokens in your text and so forth. And this is not ideal. So the byte pair encoding algorithm is a way that it can always break down any type of word into subtokens. So to show you an example, let's go briefly to this Tokenizer app again, and we will be in this video also using the TikToken app, or sorry, Python library in a few moments. But if I type some, let's say some unknown word and then something like this here, you can see it's actually breaking it down into subwords. So what happens here, maybe let's fix this, it's even nicer. So what happens here is that I bet you that this is something that was not contained in the training data for GPT-2, but nonetheless, it's able to break it down into individual tokens without failing. So without raising an error or without inserting a placeholder token or anything like that. So what happens is it's breaking down longer unknown words into known subwords. So it has, for example, seen something like some in its training set or unknown. So these are unknown words. So you can see here, it's breaking them down successfully into individual subtokens. And then if we have a string like this, this is something that doesn't really correspond to anything in the training data. It would then always fall back to individual characters. So in this case, it will just use a single character as a token. So in this way, it will never fail because it will always fall back to these individual characters if there's an unknown word. Now, this is maybe a bit inefficient because now one word becomes a lot of tokens. So it's not the most efficient way to encode input text if you have a lot of unknown words. However, it will never fail in this case. So this is one improvement over our previous method, which would just replace unknown tokens with this UNK placeholder token. So if you're interested in the byte pair encoding algorithm, how it works, so OpenAI, they actually open sourced the inference method for this byte pair encoding algorithm. So they have this GPT-2 GitHub repository. So it should be just OpenAI GPT-2. And then in this folder, SRC and then encoder, they have the byte pair encoding implemented here to break down words or input text into these subtokens. Now, they don't share the training method for this. So they only share the code that you use when you have already trained this tokenizer. However, if you're curious, I implemented this from scratch. So if you scroll down here in the bonus material of the book, so this is my repository RSBT LLMs from scratch. And then you go to this byte pair encoding tokenizer from scratch link. This will bring you to a notebook, a Jupyter notebook, where this implements the byte pair encoding step by step from scratch, including training. And then also at the end, I have a method for loading the OpenAI weights into this. So this should work similarly to what OpenAI used for the GPT-2 model. So if you are interested in more details, I recommend checking this out. But know that this is only optional. This is pretty advanced, and this is also a very long notebook, which is why I didn't include it in the book itself. Because in practice, the book is about LLMs, and this is a whole different topic. This could be actually the topic of a whole other book because it's actually quite complex. So the main message here really is that we are going to take text, unknown tokens and everything, and we have now a way to break it down into individual subtokens with this BPE method. And in practice, we are going to use the library called TikToken, which is an open source library from OpenAI. So the book, the later chapters, will implement everything from scratch because that's the title of the book, build a large language model from scratch. But I would consider the tokenizer not really part of the LLM itself. So in this case, the tokenizer here, we are going to use this library from TikToken because it's actually also very nice and efficient, and it's what most people use in practice. So the reason why it's efficient, for example, more efficient than this implementation here, this other implementation here from OpenAI, is that the most expensive function calls or code is implemented in Rust, where Rust is a different programming language that is often used to implement high performance code. And then to make it easy to use, people usually add a Python API around this. So we're going to use this library in Python, but most of the core parts are implemented in Rust to make it really fast in inference. So what we're going to do is we're going to import the TikToken library. Here we go. So the TikToken library is helping us then to use this GPT-2 tokenizer. And by the way, why GPT-2 and not GPT-3 or 4? That's because later in chapter 5, we will be training a small GPT-2 style model. And then we will also later see how we can load the pre-trained weights from OpenAI, who shared the GPT-2 model weights. Unfortunately, they didn't share the GPT-3 or GPT-4 model weights yet. But the architecture of GPT-3 is the same as 2 and so forth. In any case, so we are going to use the GPT-2 tokenizer to make it compatible to the model we are going to implement later in chapter 5. And we can import the TikToken library like this. If you have set up your Python environment as described in the first video with this requirements.txt file, this should automatically work. If you get an import error, that means you probably haven't installed the TikToken Python library. So you could either use uv pip install or just pip install TikToken to install this library. So if you would execute this code cell here, this would install the TikToken library. So, but I'm commenting it out because I have it already installed. And so next, let me also just briefly double check which version I'm using. So it's always a habit of mine to double check because you never know if you run the notebook in a few years in the future. Maybe if you get a different result, it could be due to a different version of the library. So I'm using 0.9, but it should also be fine if you have an older version like 0.7 or 6 or something like that. But if you get some weird results that don't really match what you expect, making sure you have the correct version is never a bad idea. So you could then also fix this version number like this, for example. Okay, so how are we going to use the TikTokenizer now? So we are going to instantiate a new tokenizer object, and we are going to use the GPT-2 tokenizer, like I mentioned before. So we do get encoding and then GPT-2 like this, and this would instantiate the GPT-2 tokenizer with the full vocabulary, the way it was trained and everything. So this is already ready to use. We don't have to train anything. And then the usage is exactly the same as our own simple tokenizer. This is why we went through all the work here implementing this, because it helps, I think, illustrate how encode and decode work, like these methods. And this TikTokenizer is using exactly the same API. So you can see we are encoding this now, and then there's also tokenizer decode like this, and this gives us back the original text, which is exactly what we had before. Now, let me actually show you a more advanced case where I have some copy-pasted some text here, and let's actually try to encode this text. So before I mentioned to you that it can handle arbitrary words. So it is actually able to, break down any words into subtokens. So let's see actually what happens. So you may notice now that actually it raises an error. And why is that? So there is one interesting thing about the GPT tokenizer. And so one is that they use the so-called special end of text token. And I think I glanced over this in the previous videos, but the end of text token is usually used, if I can find the figure here, it is usually used to concatenate texts. Let me double check. Yeah, here. So when you are preparing the data set for training an LLM, you usually have multiple documents. And to signal to the LLM where one document ends and where the next document starts, you usually add this end of text token. You can either add it at the beginning of the next document or at the end of the previous document. That doesn't matter, but you usually have this end of text delimiter to show where a new document starts so that the LLM knows, okay, this is a new document now, it's not part of the previous document. And this is also used in GPT-2, for example. And it's a special token that they used, but it's not by default enabled in this tokenizer, which is why it's complaining. So what you have to do is you have to, unfortunately, add this as a special token. So you have to be very explicit here and then add this special token like this. And yeah, you can see this one works now. And so this end of text corresponds to 50,256, which is essentially the vocabulary size of this tokenizer. So the vocabulary has 50,256 entries in this case. And so one more thing I wanted to mention is it might look like it's not working well with things that is not denoted as allowed special, but it would work with any other token. So I can just, add arbitrary text here and it would work like this. So like we said before, it can break down arbitrary text. It was just an exception with this end of text token. And so this is in a nutshell how the byte pair encoding algorithm works. So it's essentially a method for breaking down arbitrary text into subword tokens. And if you are curious about more details, how it's implemented, I highly recommend or not highly, but I suggest checking out this source code. I would say I would not highly recommend it at this point because it's pretty advanced and it can, it can be a bit confusing. And yeah, if you like, you can also check out my implementation here where I added a few more comments and hopefully making this a bit more readable. But yeah, again, this is advanced material. I would say this would be almost topic for another book. It's not really anything you have to necessarily understand for implementing an LLM. The core message is we have now an algorithm that breaks down text into tokens. And in the next video, we will talk about implementing the data sampling.
Get this book at manning.com.